Welcome. Today I'm going to be covering electrolysis, which is an essential part for your chemistry IGCSE exam. So let's just dive right into it. Here are some basic definitions. You need to be able to write down the definition of electrolysis because it has come as a 1 or 2 mark question. It is the decomposition of an ionic compound when molten or in aqueous solution by the passage of an electric current. It is important for you to mention molten or aqueous, and they can ask why must it be molten or aqueous. The reason is that you are going to be passing electric current, and for it to be able to conduct electricity, there needs to be free moving ions. And free moving ions are obviously only available when the compound is molten or when it is aqueous. If it is in the solid form, then it will not have any free moving ions, therefore will not be able to conduct electricity, and then you cannot perform electrolysis. Remember, our ionic compounds are our nonmetals and metal, or actually write it down as metal and nonmetal. So NaCl as an example, sodium is metal, chlorine is nonmetal, and this is an ionic compound. The electrolyte is basically the ionic compound itself in either molten state or in a dissolved solution. Now this is basically our main structure of electrolysis. We have electrodes over here, and we have the electrolyte over here. So we have 2 electrodes. We have the anode and we have the cathode. The anode is the positive electrode and the cathode is the negative electrode. Now it is essential for our electrodes to be inert. Therefore, they can either be carbon or graphite. They might ask you, why should the electrodes be inert? It is because you do not want them to be interfering with the reaction. So to prevent interference with the process. And it is a common question for them to ask why you would use graphite as an electrode. So your 2 reasons would be that it is because it's inert and also because it conducts electricity. Now I'm going to be basically explaining the basic working of electrolysis, and we are going to be working with these 3 examples. So we're going to be working with NaCl in molten form, NaCl as a concentrated aqueous solution, and NaCl as a dilute solution. So let's start off with molten because it's the easiest. When you're given the compound and you have to figure out the product, I want you to make a table of the ions that are available. So NaCl in the molten form, you have Na plus as 1 ion, and you have Cl minus as 1 ion, and these are the only ions that are available in the compound. Now you're going to need to have to specify which electrode has which product forming. So the chloride ion, which is a negative ion, will be formed at the anode. Why? Because this is a positive electrode and opposites attract. Here the positive ion will go to the negative electrode again because opposites attract. That's a very sad circle. You can also remember it this way. Positive ions are called cations, and cations will go to the cathode. Negative ions are called anions, and anions will always go to the anode. Now, NaCl in concentrated, as a concentrated solution. Now, in your exam, they will specify if the solution that you're working with is concentrated or dilute, mainly because the final products that you will be getting will be different. Again, I want you to draw a table. You get Na plus, Cl minus, and this time you also have H plus and OH minus, because this compound is dissolved in water. So you have the ions of the compound as well as the ions of water, which are hydrogen and hydroxide. Now, when it is concentrated, and this is the main distinction between concentrated and dilute solution, your halides will take part in the reaction. They will be the ones forming the product. So over here, hydroxide will not be taking part in the electrolysis process. We will have chlorine go forward to anode. And the product that will be forming is chlorine gas. It is very important for you to say gas because they do not want you to say that chloride ions are the ones that are forming. That is not the final product. The final product is chlorine gas that we can collect and we can use for whatever industrial processes that we need chlorine for. Now, on the positive hand side, you need to work with reactivity. Always the less reactive one will go forward. So the less reactive one is the one you are looking for. If we look at the reactivity series, hydrogen is much less reactive than sodium. It's all the way down there. So over here, hydrogen will go forward to cathode and will form the hydrogen gas. They will ask you for basically which products are formed, and it is possible for them to ask you at which electrode, so that you know now. However, if they ask you for 3 products, then you have chlorine gas, you have hydrogen gas, and the ions that are left behind are sodium and hydroxide. Therefore, you will get sodium hydroxide. As a third product, which is obviously, sodium hydroxide is a very important base in chemistry overall. So if they give you 3 blanks as to how many products are there, or name the products that are formed by the electrolysis of concentrated sodium chloride, you're going to say hydrogen gas, chlorine gas, and sodium hydroxide. Now, if we take the same solution but in dilute form, you will see that there is a change in products. Once again, Na plus, Cl minus, H plus, and OH minus. Now, since it is a dilute solution and it is not concentrated, your chloride ions, or basically any of your halides, they will not take part in the reaction. So since the chloride ion won't be taking part in the reaction, you're going to have hydroxide go forward to anode. And the product that the hydroxide ion forms is oxygen gas. Always. Once again, over here, hydrogen is less reactive, so hydrogen gas is formed. This is basically the only distinction that you're going to have to work with between concentrated and dilute. In concentrated, your halides are taking part in the reaction. In dilute, your halides are not taking part in the reaction. And you will have oxygen gas forming at anode. One last example that I would like to discuss is the silver nitrate ion. Not ion, ionic compound. Aqueous. Now, I am not specifying for you if it is concentrated or dilute because in its case, the products won't change, but in the exam they will specify for whichever compounds that is necessary, that specification is necessary, they will specify it for you, and you won't have to be confused and figure out exactly what they want. Your ions will be now, this is a very important distinction or very important point for you to remember. Spectator ions, which is nitrate as well as sulfate, they never take part in electrolysis. Under any circumstances, be it concentrated, be it dilute, you will not have these spectator ions take part in the reaction. So, since this is gone immediately, you have hydroxide go forward to anode, making oxygen gas. And over here, silver is less reactive than hydrogen. Here you can see silver, and this is hydrogen. Silver is less reactive. Silver will go forward to cathode, and the silver metal is formed. Okay, that is basically the main working that you're going to have to work with in the exam. This is the basis, the foundation of electrolysis, and I have given you the different types of small 1-2 mark questions that they could ask, and it's very important for you to keep in your mind because they are repeated. They're the basic information that a student is expected to have. So why is it molten? Because it needs to be able to conduct electricity. Inert, because you don't want interference in the process. Graphite, because it's inert, conducts electricity. And this is the basic working. In my next video, I plan on covering electroplating, which is a much smaller topic and it will not take that much time. So if you guys found the video helpful, please tell your friends, if anyone needs it, forward it to them, like, subscribe, I don't know. And if you have any questions, do comment down below and I will try to answer as soon as I can. Thank you.